Alright, and here we are. Here we are with the stream, baby. Alright, we're doing more homework today. Let me go grab the homework problem so you can take a look at it while I share my link everywhere. Alright, the stream's begun. It should be working. Let me check my YouTube channel. Alright, let's see. Yep, it's here. Alright, let's see. Alright, okay, hold on one sec. Let me check the filter. Noise gate, I'm gonna make the... How much noise is it? How much noise do you guys hear if I do this? Let me see. Is it better? Can you guys hear me well now? Let me see if... Can you guys hear me well now? Okay, yeah, the noise is much better. Alright. Let's see. Next up, I'm gonna share the link. Right, share the link. You guys can look at the problem we'll be doing today. This is the first problem. Spoiler alert, okay, so fun fact, the teacher taught us about the integration factor technique for solving differential equations. This question, I think they wrote it wrong. So basically it means that this problem you can't solve it with the strategy they taught us. So that means we're going to need to use another different strategy. Alright, let me just go into the self-promote. Okay, which channel shall I send this? Solving differential equations and doing classical mechanics problems. And then I paste the link and I copy and then I send this every fucking where and we'll start. Which I don't want to like post it too much like everywhere because I don't want to, because there are some servers in which I'm not active, but like yeah, I don't want to like be there just like I don't post anything there, just sending images, no, just sending my links there, because it would look really bad if I do that, you know. It would look like I'm just there for the sake of self-promotion. Are you in a classroom now? I'm not. I was yesterday, but today my professor is actually, what is it? My professor is a little busy having a surgery, so he's not teaching today. So I'm free for an entire day today, and so I've been working on my video. You sound like you are. Yeah, the acoustics may sound like it's... Yeah, I'm in a fairly empty room because this is how my room works. I moved to my room. My room is on like the 4th floor of the house, and so I haven't renovated it. There's like no furniture apart from the bed, and there's a few sofas over there, but like apart from that, the room is pretty empty. So there isn't many things that would absorb the sound. So there's a lot of reverb going on, which could be a reason why. Okay, well, I'm gonna see where else can I post a link before I start. I don't want to post a link in a few of these because I don't want to like overshadow the other people's links yet. I'm gonna post this here though. Never mind. Thank you, Neon. Thank you. Okay. Alright, so let's begin. So today I'm doing two subjects homework today. There's the differential equation and the classical mechanics. Get fucked. Alright, so there's classical mechanics and differential equation. We're doing differential equations first, and then we'll do classical mechanics. Find an integrating factor and solve the following differential equation. Basically, this problem would come from this form. Hold on. Normally, when you have a differential equation, there are some differential equations that come in this form, right? There are differential equations that come in this form, and I showed you how to do this last time. I'm not. What was it last time? Anyway, it might not have been last time, but it doesn't matter. What matters is that this is a differential equation that you can solve by assuming there's some sort of function phi such that taking the derivative with respect to x is going to give you m, and taking the derivative with respect to y is going to give you n. Both of these will result in both of these will mean that the implicit differential of this function. Ooh, thanks for the hearts. I actually did not know that was a thing. Yeah, I did not know that was a thing before. Thank you for the hearts in the live chat. I don't know if it's shown in the overlay, chat overlay. This means that this whole thing is going to be equal to dphi by dx plus dphi by dy and it's equal to 0, which means that this guy is a constant, which means that some x, something with x, plus something with y, plus something with x and y, they must be equal to constant c. Don't forget to add a c, thank you. Yeah, this is a c. So what that means is that we have to find such, where's my layer 2? There it is. Which means we have to find some, we would have to find this phi. Unfortunately, in our case, we cannot use this strategy. If you want to see how to use that strategy, I think there's an older stream. I think it was like 2 streams ago in which I did that, or maybe it was last stream. I don't remember anymore. Give me a sec. Plus or minus. Yes. Yeah, it was 2 streams ago where I did that. But here we can't do that anymore. What we have to do is employ another strategy. Let me rewrite this equation real quick. This, I forgot I'm still using white. Okay. Let me rewrite this equation. I'm gonna move this whole thing over to the right hand side of the equation. So we're gonna have x squared plus xy times dy equals to x squared minus xy times dx. Now what we do next is we bring the dx over to this side. It's not really a mathematical operation. It's not mathematically a valid operation, but we're physicists. We can do that, and this one is going to become dy by dx, the differentiation of y with respect to x. And on the right hand side it becomes, actually no, there's a negative sign here, thank you. And on this side it becomes negative y squared minus xy. Okay, and then what we're going to do next is I'm going to bring this thing over to this side. So we're going to isolate dy by, no, not y squared, why did I write a square there? Anyway, dy by dx. I'm going to be going a little more quickly over for this one because was I have like 2 sets of homework. One of them is this one right now is actually assigned like last week, and I have to send it in today. I just didn't stream it yet because I thought that there wasn't much. Like it would be a half an hour stream if I were to do this, so I just kept it to stream with make a double homework stream. So this one I can factor it out. Would be y over x, and y minus x divided by x plus y. All right. So that's that, and yeah. Now what? What do I do next? Wait. Okay, yeah. I'm gonna change. I'm gonna use the variable u here, and I'm gonna define it to be y over x. So what we have here is it means that dy by dx, right? Dy by dx is gonna be equal to derivative of ux with respect to x, which would become u prime x. I'm going to shorten the d by dx to prime, and then add it to u. So it means that the dy by dx up here, we can change that to u prime x plus u. On the right hand side, we change all instances of y over x into u, and then that's going to be y. I'm going to pull out x, so this will be x, and then that would be u minus 1, and they're going to be divided by x times 1 plus u, which becomes negative u times I'm going to remove the negative sign actually. So this becomes just u, and then up there becomes 1 minus u divided by 1 plus u. And so the rest is kind of simple. All you have to do is just write this u prime x is going to be equal to u times 1 minus u over 1 plus u subtracted by u. And to add them up, I would have to make the numerator. I actually don't know. Okay. So fun fact: I've never really known which one is the denominator or the numerator. Like genuinely, I don't know the terms. I just thought of it as the upper number or the lower number. Like because English isn't my first language, obviously. So when we were just taught like the upper number has the Thai name, the lower number has the Thai name. So I just remembered with that. I never really remembered which one is the denominator and the numerator. You'd say, yeah, I know, right? So which one is it actually? Which one is the denominator? And the denominator is the bottom number. Well, that's that. The denominator is the bottom. So in this case, we would have to make sure the denominator would be the same. So here we would have u, and then it would be 1 plus u divided by 1 plus u. These two equations are equal because this term is u multiplied by 1. This whole term just becomes 1 as well. So this operation is valid. Obviously, you know how to add fractions. This just becomes u, and then this becomes 1 minus u minus 1 minus u divided by 1 plus u, which simplifies to, I don't know why my algebras are acting up. Like, it's probably my room right now that's like, I haven't cleaned this room in a bit because, again, this room I don't really use because it's all the way upstairs, and like on top is like the uppermost floor of the house, so it's getting the energy directly from the fucking sun. This is negative 2u. Not again. Hello, Macabre. I hope I pronounced that right again. Yeah. Welcome back to the stream. Here we go again. So yeah, I'm on the topmost floor of the house, which means that the heat is gonna be insane during the day, and that is why I don't really stay up here until the air conditioner until we have enough money installing anytime soon. Loud and correct buzzer. Thank you very much. And I'm gonna try it. That's macabre. I think that's how you pronounce it. I swear to God, I looked it up some time ago. Let me. Because there are two pronunciations. There's the
Macabre.
macabre. Yeah. I said it about that, right? But there's also the American pronunciation.
Macabre.
Which I was like, why? Why are they different? Anyway, no, don't even try. Alright, I won't. So yeah, my room is in the uppermost room of the house, so obviously it means that I'm gonna be, in Thailand. You know the heat in Thailand is, southeast. It's the fucking equator. We're at the fucking equator. The heat is gonna be insane, obviously. So anyway, gonna make this -2 over there actually. So when the heat is crazy, I probably wouldn't be living up here in this empty. Is it macabre? I don't know. Those two TTS are wrong. Compare the correct version, which is literally called the corruption culture. Okay. One sec. There we go, correct. Okay, macabre. Then what the fuck's wrong with the Google pronunciation? Oh, actually I can provide feedback. Choose what you're giving feedback to. I can actually provide feedback to Google. Do you guys ever use the that feature in Google? Great job, Neon. You got it right. Thank you. Nope, yeah, me neither. Google, what do you expect? But it could be also because of the way we pronounce it. Fair. Fuck Google. This will be plus natural log view. Of course, there's going to be a plus c. I'm going to put the plus c to the right hand side. Natural log of 1 over x squared plus c. Okay, so in case you don't know what I did there, this equation is a separable differential equation. We've solved separable differential equations before. What you do is you move the function of u to this side where the u prime is, and you move the function of x to the other side where the x is, and then you move the dx. So u prime here is just du by dx, and someone's calling. All right. It's the default ringtone, yeah. It's the default ringtone. Okay. Actually, my auntie called to go and look at the cats. Can I go look at the cats real quick? While that happens, what do you guys want to watch? While that happens, actually, I'm gonna make a new. While that happens, I'm gonna go I'm gonna go look after my cat for I'm gonna make a little. Please wait. part of the street. So I'm gonna go take a look at my cats real quick. I'm gonna put like the fan blowing for 10 hours straight. Okay, yeah, bet you're gonna be a huge fan of that. I'm trying my best. So yeah. Okay, yeah. I'll be back, and I'll solve the rest of the equation. Actually, if you want to, you can solve it yourself and tell me the answer. You can solve. You can do the rest of the equation. I'll be back in like 5 minutes. You guys can have fun. Uh, yeah. Actually, is any of the music copyrighted if I play the music in my playlist? I feel like they would be. So I'm not gonna risk that. Well, yeah, gonna see you guys in like. Oh, I won't be long. I won't be go for long. I won't go for long. Okay, guys, I'm back. How did you guys? Did you guys have fun? What? Uh, so as aforementioned, my house is like on the top floor of the house, whereas my cats are on the bottom floor. So I had to run all the way down and come all the way back up. But I hope that wasn't too Give me a sec, guys. Hope that wait wasn't too long. So anyway, now that we have this equation, we can exponentiate it, which is going to get us u times e to the negative 1 over u is going to be equal to k over x squared. K here is just c to the power e to the power c. I forgot to have chat open. Hold on. Are you real? Yes, I am actually paid for yapping about nerd stuff because I'm a tutor. I don't get paid much because I only tutor like 2 or 3 kids. But I do get paid technically. So technically, I am a professional yapper. I'm a professional nerd yapper. So now we can solve this, and now I can just turn this into not x. It will be y over x times e to the negative x over y. It's equal to k over x squared. And so this solves our equation. And that's our solution to this differential equation. We don't know, okay, I can get us the explicit form, but we weren't taught this. I learned of this function when I was doing my projectile motion video. It's called the W Lambert function. Allow me to elaborate. Before that though, let me see. Okay. I'm gonna write this as a function of y as a function of y as a function of x. Yeah, sorry. Okay. I'm gonna write this as y as a function of x. What we can do is we can turn this into 1 over u times e to the 1 over u is equal to kx squared, which means from here I can bring the functions to the other side, so it's going to be x squared over k is equal to 1 over u e to the power of 1 over u. K is again any arbitrary number. And now we use what is known as the W Lambert function. I'm going to change k here to big K. So now we use the W Lambert function to apply this on the left hand side. Yeah. And it's going to undo the 1 over u e to 1 over u. This one will just turn into 1 over u. Because the W Lambert function has a property. By definition, the W Lambert function is a function such that x equals to wx e to wx. In turn, you can prove that for real numbers, for the case of real numbers, the W Lambert function of x, the W Lambert function of x e to the x becomes just x. You can prove that this is the case. And so I use that. I apply the W Lambert function on both sides of the equation. That way it would give the same function. And so we have w equals 1 over u equals to x, equals to x over y, and therefore y is equal to x over W Lambert function of, I'm going to call it small c, x squared. C equals to 1 over x, of course. 1 over k. And this is our solution to the differential equation above. So we don't find the integrating factor because the integrating factor can't be found as a function of either 1 or 2 variables. It has to be both variables. And that is going to make it even, and if we have to find that, it's going to be an even bigger problem because we can't use it using any normal way. So yeah, we just solved the differential equation. We get y equals to x over w cx squared. Playing Russian roulette right now. Nice. I don't know what that means. Or what are you talking about? All right. Next problem is a little long. Let me go grab that real quick. Width is 21 centimeters by 29.7. Oh, don't worry about it. Okay, sure, I won't. Okay, this is our next problem. Let y be the vertical displacement of the mass from its equilibrium position. We call that the force of M due to the stretch or compressed spring is then negative ky, and where k is the spring constant, and the minus sign indicates that the force and displacement are opposite. Okay, you get the idea. Basically, what they want you to know is that this is the equation that you have to solve, and these are the initial conditions. So when you solve a differential equation, like for example this one, this was a first degree differential equation. Every Russian roulette player we interviewed survived. It's called a survivorship bias, I think. But they all survived, so it probably makes sense, right? Russian roulette is 100% safe. So back here, we solved the differential equation, and we got 2. And we got, this was a first degree order differential equation. First order. Yeah, first order differential equation, because we took the derivative only once. But here, which in the end, the final answer, we had one unknown variable. On the other hand, over here, this is a second order differential equation. Second order differential equation means you're going to have 2 unknown variables at the end. Could be like a and b or something. Either way, you're going to end up with 2 unknown variables. And those 2 unknown variables, for our case, they gave us the initial conditions. These initial conditions will tell us what those 2 unknown variables are, what the value of those 2 variables are, and after that we're going to be able to find the true solution to this problem. So let's just, we don't really need to read the rest over here. What matters is just this equation, and we have this omega thing over here that we'll be dealing with in a bit, but not yet. What we have is d by dt, the second derivative of y with respect to time. Gladly redacting myself and feeling big shot in Russian roulette. I mean, if you get to live at that point, then you are a big shot in Russian roulette. It's kind of like quantum immortality in a way. I don't know why my nose is getting a little fucked. So when it comes to having a second order differential equation like this, I actually prefer to write it like this actually. Plus k over m y, but I'd rather not write it as k over m, because I'd actually write it as omega squared y. Over here, omega squared is k over m, so we can substitute it like that, and it's going to be equal to 0. Okay. Once we're done with this, we're going to have like a little 5-minute break where we talk about some random thing. I don't know. Here, what to do when it comes to having a second order differential equation like this. What you gotta do is, if it's a linear differential equation with constant coefficient, in our case, the constant coefficient means that over here there's 1 multiplying the dx, the dy squared. Over here there's omega squared multiplying the y. So here the differential equation is linear with constant coefficient, because omega here doesn't depend on t, it doesn't depend on y. So this is a constant. 0 here obviously is a constant. So when it comes to these kind of equation, what you do is you assume that y is equal to some function of t e to the power of rt. Why is this? Well, if you take the derivative of e is twice, right? If you take the derivative of e twice, you're still gonna get, if you take its derivative twice, you're gonna get the same function, because that's what, that's the property of the exponential function. If you take its derivative, you're gonna get the same function multiplied by some value. In our case, if we take the first derivative of y, we're gonna get r e to the rt. This is according to chain rule. And if we take the derivative of it again, we're gonna get r squared e to the rt. This is why we assume it like that, because once we have the same function, we can kind of just, if you add them up, it would eventually negate each other, and you're gonna end up with, and on the right hand side will indeed be 0. Bottom line is that if you see this kind of equation, just assume just assume that y equals e to the power of something. So now we take, once we plug this whole thing in, we're going to get the fact that r squared e to the rt plus omega squared e to the rt, because y is rt, and it's going to be equal to 0. What is r? We don't really know yet. It's going to be it's going to be what is known as the frequency of the equation, which is going to be equal to this guy. Soon enough, you'll see what I mean. So now we know that we can cancel rt here, because we can factor it out and then divide by 0. Divide the 0. So we're not going to divide by 0, because e to the something is never going to be 0. Yeah, it's never going to be 0, so we can't do this. And we're going to end up with r squared plus omega squared equals 0, which means r is equal to, there will be two values of r. It's going to be r equals to plus or minus I omega. Because I omega here, I equals to, I is the square root of -1, right? I is the square root of -1, which means that squaring r here is, if I square this guy, it's going to be negative omega squared, plus omega squared should be 0. Makes sense. So therefore, if I square this, you can verify this, that this is true. Therefore, there will be two possible values of y. The first y is equal to e to the power of I omega t, and the second y is when is e to negative I omega t, because we found out r to be this guy, so we plug it back in. And if you plug y1 here back into this equation, you can verify that this is true. The equation will be true. So y1 is indeed the answer to it's indeed an answer to the equation. And then you plug in y2, and it turns out that this equation will still hold true, which means that both of these equations will be true, right? Both of these y's will satisfy the equation. So what if we added them up? If we add y1 and y2 together, will it still be a solution? So let's try that. Let's say we have a value of big Y equals to y1 plus y2. Will this equation still be true? Well, let's try that. The solution will it will become y1 double prime plus y2 double prime. Wait, no, I forgot the omega squared. Plus omega squared big Y. If you take the derivative, you realize that the derivative operation is linear, which means that this is going to become omega squared y1 plus omega squared y2, and should be equal to 0. Now, question is this true? Yes, because y1 double prime here and omega squared y1 here, both of these cancel out to 0, because according to the fact that y1 satisfies the equation. y2 here and omega squared y2 here also add up to 0, according to our equation. Sorry. And therefore, according to all of these, it means that big Y here is also a solution to the equation. So adding y1 and y2 indeed gives you the solution to the equation. Apart from that, if we scale y1, we're going to get something like ae to the power of this thing. And if we plug it back in there, you'll also realize that it is still true. Therefore, y1 can be anything as long as y1 can be this function scaled by any random number, a. In the same sense, y2 can be scaled by any random number b, and it will still hold true. It will still make the equation true. And then you can also add those two up. And so the overall solution, the general solution, is a e to the I omega t plus b e to the negative I omega t. The general solution is y equals to this whole thing. And it is going to be true, 100% true. No matter what a is, no matter what b is, if you plug it back in there, it's still going to be correct. And this is our general solution. But our case is not general, because we do know that at the start, at t equals 0, this whole expression must be negative 10. And if you take the derivative of that, it must be equal to 0 as well. So we would have to find something that would satisfy that equation, that would satisfy that condition. So let's do that. We do know that y at t equals 0, y at t equals 0 must be equal to negative 10, and it's equal to a plus b. If you plug in t equals 0, that whole thing becomes 0. E to the 0 is 1. Same thing applies for this guy, so it becomes a times 1 plus b times 1. You get a plus b. Then we have y prime of t equals 0. It's going to be equal to a times I omega minus b times I omega. And it's going to be equal to 0. Because I took the derivative of e to the I omega t. And then you get these, and then you cancel out the I omega because you can bring it to this side, it becomes a minus b. Therefore, a and b are equal, and therefore a is equal to negative 5 while b is equal to negative 5. And therefore, the general solution y equals to the general solution of y here is going to be equal to negative 5 centimeters times e to the I omega t plus, well, not really plus, minus 5 times e to the negative I omega t. This is our solution to the problem. Yeah, so this is the general solution. If we have this equation, then, okay, let me zoom out. This was the general solution. If we had these equations, so it's 5? No, it's negative 5. If we have this general equation, we would have the general solution to be this one. But then we have this, which is why. But then we have these initial conditions, which guarantees us that there's going to be only one solution, and that is a must be negative 5, b must be negative 5. And this is our answer. And why do you pause? I had to think for a second if we're on the same page. All right, and this one is gonna be -10 cos omega t. This is a bit of a leap if you don't know. Basically, by if we use the complex definition of cosine, cosine x is equal to e to the ix plus e to the negative ix times 1/2. This is like the complex definition. If you consider if x is a complex number as well, then this is how you can find the cosine. And this is indeed true in this case, so y is equal to -10 cos omega t. And so once we have this whole thing set up, we know that if our initial condition is this, we know that at any time t, what the value of y is going to be. That is, if we had this spring thing going and we pull it down, it's going to be at -10, and its initial velocity is going to be 0. And if we release it, we know that then afterwards what its value is going to be, where it is going to be. So here we start here, and then it's going to oscillate up and down, up and down, up and down, like a cosine function. And that is our answer to this question. See, this is why I didn't screen this homework last time, because it's just, how long is it? 4 to 6 minutes. It's going to be a 4 to 6 minute stream. It's not worth it. It's not worth the setup. Okay. And that is our answer. So, any question? No? Good, okay. Alright, lovely 4 minutes of background noise while I have dinner. Yeah, that was nice. You guys want to hear more background noise? Wait, 4 minutes? You finished dinner in 4 minutes? Anyway. So yeah, that's our first subject done. The first subject was differential equations. The next subject is classical mechanics. Before we do this, let's have a short little chat. I don't know. Do the same. You guys eat dinner at this time? No, I have way more to eat. Keep going. Alright, I will. I finished mine in like 1 or 2. What? You just how? How do you finish dinner in 1 or 2 minutes? It takes me at least 20 minutes to finish my dinner. How do you just? I'm not even gonna question that. What? I'm fat. Yeah, just don't choke. All right. Just don't choke on your food. I'll be sad. Okay, hold on. Let me close that thing. Yeah, don't choke on your food. I'll be sad. So you eat one broccoli, leave. No fucking shot. Okay. Yeah, so what the hell? How do you even? I'm genuinely impressed and scared. Like a full lunch? How? Like, what is the rate of each bite? You like eat, like, does each bite take you like 2 seconds? That would be insane. Okay, anyway. Oh yeah, let's say when I get hangry, I eat quick. Okay, cool. Yeah, I know. I love it when you're hangry. Alright. I am a little hungry. I feel like it's like one more hour. I normally have my dinner in like an hour or an hour and a half. That's when I normally have my dinner. So I better get this each question done in like 20 minutes. All right. So yeah, don't ever fucking say that again. Okay, sure I won't. Okay, you know what? Break time's over. Let's just continue on this question. Actually, fun fact, I'm almost done with my video. And by almost done, I mean like I finished my video, actually. I just need to export it and then make the thumbnail for it. If I finish the stream sooner than I thought, I probably would just start making the thumbnail on stream. I think I want to do that, yeah. But let's do this one first. Two hobos, each of mass mh, are standing at one end of the stationary railroad flat car with frictionless wheels and mass mfc. Either hobo can run to the other end of the flat car and jump off with the same speed u relative to the car. And A, use conservation of momentum to find the speed of the recoiling car if the two men run and jump simultaneously. And B, what is it if the second man starts running only after the first has already jumped? Which procedure gives the greater speed to the car? Okay, sure, let's do that. So for A, let's just use conservation of momentum. Initially, the total momentum initially the initial speed of the car is the initial momentum in total is going to be 0, right? Because the car, assuming I can draw it well, because I can't draw a straight line for some reason. This is foreshadowing, so anyway. Okay. Then we have two guys on top here. Then we have a car over here. The total momentum initially is 0. Because no one is moving at a time. And then P at the end, the momentum at the end, must be equal to something. So I'm going to define that something as, one sec. I'm going to find the final velocity. I'm going to say the final velocity is v. The final velocity of the car is going to be v. And the final velocity of the person while jumping off the car is going to be, relative to the car, it's going to be u. So that means the velocity of this person would actually be, to this direction, v minus u. Because that's how relativity works. Galilean relativity, not special. If you want to learn more about special relativities, hit that subscribe button, because I'll be dropping it in a few days. Once I'm satisfied with the thumbnail and written out the description. Anyway, the final momentum is gonna be first. It's gonna be the momentum of the car, which is gonna be mv. And then you are gonna add the momentum of the person, of the two people who have the same mass. So we can consider them to be like the same person with double the mass. So it's gonna be 2mh. And then multiplied by the velocity to the right, which is going to be v minus u, because according to this, the speed u is the speed relative to the car. It has the same value for both, and it's the same in A and B. Yeah, okay, yeah, that makes sense. Okay, so this person can run. So that's the ending momentum. So now we write out the equation. mfc v plus 2mh v is equal to 2mh u, right? Because this one must be equal to 0 for conservation of momentum, because because the floor is frictionless, right? And then so this must be 0. I distribute this in, move u to this side, and we have that, and therefore v must be equal to 2mh over mfc plus mh plus 2mh, and then multiply this by u. Boom. Makes sense, right? Let's say, for example, if mh is very small, if the value of mh is very small, then this one up here could just be taken to 0 divided by m of something. The final velocity is going to be very small as well, because the mass of the person doesn't really change. On the other hand, if mh is really big, if the person is like much bigger than the car, then the velocity, the final velocity is going to be equal to the velocity that the person is running out. Would that make sense? Actually, yes, that makes sense. Alright. So yeah, that makes sense. Perfect. And this is our first answer to the first question. Conserving momentum, find the speed of a recording car with the 2 men run the jump simultaneously. Alright. Any questions for this problem? For this answer? Anyone object this answer? You guys agree that this answer is good? Okay, cool. Moving on. Moving on, let's consider let's consider 3 intermediate steps. 3 steps in total. First, of course, is the initial velocity, the initial momentum. The second is the first jump. The first person has jumped off, and this is going to be our first. This is going to be our P1. P2 is going to be the second jump, where the second person jumps off. So I'm going to write it as P2. So let's see. P1 here is going to have, the person is going to jump off at a speed u. No, u relative to the car, which means that his actual velocity would be v minus u. v1 minus u. Holy shit, v1 overkill. And of course, the other person is also going to be moving at v1. And this is going to be the total momentum during the first moment, P1. So we will write that out. Let's write that. What are we gonna get? We are gonna get mh times v1 minus u plus mh plus mfc times v1. Okay, this part is the mass of the car. No, this part is the momentum of this guy jumping off. This part is the momentum of the guy and the car still going. Next up, we have this guy still going at the same speed. We're assuming that we're in space here. The other guy is still going at the same speed. We're assuming he's in space, so there's no force acting on him. And then this guy next is also going to be at v2 minus u, while this object is going to be going at v2. What we want to find is we want to find v2. v2 is the velocity after the second jump. And yeah, now we set up the equation. mh v1 minus u plus mh v2 minus u plus, let me move these guys out all the way real quick. Okay. And then plus MFC V2. Okay, now we have that, and now we try to solve the equation. Give me a second. I need to sneeze, but I can't. So it's kind of stuck on my nose, and it feels really unsatisfying. Yeah, let's just set up the equation. We have equation 1 is P1 equal to P initial is equal to 0. Yeah, it's equal to 0. That means MH of, I actually want a thinner stroke. Can we do that? Oh wait, I took this before. Oh, you had that before? You've had this question before? That's great. Because yeah, I remember this question too, but like I didn't fully do it, I think. But it was in the case where there are actually like an infinite number of people, of very small people. So how did it go, Leon? How did the solving go? Image plus MFC. Yeah, but I can't remember like 95% of it. That's fair. That's fair. At least you remember you did it, and you ended up. At least I don't fucking know. At least you knew how to do it, I guess. I move this to the right hand side, so we have MHU is equal to 2MH plus MFC V1. Pain in the ass. Fair. You know, the usual. Fair. So now we have V1. Ultra is equal to MH over 2MH plus MFC, which we shouldn't really have to. We shouldn't have to write this, honestly. We just got it earlier. We just changed them. We should have just changed the math a little bit, but we got it nonetheless. We got this V1 equals to that. And so next up is P1 and P2 must be equal. P1 equals P2. Momentum of after the first jump must still be equal to the momentum of the second jump. Hello, welcome Testy. Welcome to the stream. It is more homework, physics, yes. I'm actually enjoying a lot of these physics homework. Although, yeah, because like, it gives me content to stream and interact with my channel, making sure that my channel actually doesn't fucking die. But there are some other homework which are a little annoying. For example, there's this one. Yay, fun homework content. There's like this essay homework. There's an English homework. For some reason I still have to take English even in university. It was a compulsory course, even though my English. I don't think I need another course in basic English. I don't think. But this course is a course in fairly basic English. I hope it does pick up the pace a little bit, because I feel like it would be useful for me in the future if I do get to learn like more like English. Yeah. There's also the science communication, which also gives off quite a bit of homework. The other day, the other day it was like a homework on. They want us to make an infographics for our homework, scientific. It was for science. The class is science communication, so obviously they want us to make like science infographics and shit. I want to show it to you guys actually. After this question, I'll do it after this question. Let's just solve this equation for now. It must be equal to MH. In fact, the homework. There's this English homework that I haven't done. It's due next week. Basically, I have to like go and take a course in MOOC. I'm not quite sure what it stands for. I think it's something like massively online something course. Basically, it's just a course that you can take online. You may get a degree if you pay some of them, but like you don't. It's not. Most of them are free, kinda. So like I have to go look into those and then write out kind of like a reflective essay about like what I think about the course I took. And I haven't started because I felt like I could do it in like half an hour, which honestly I probably could because I'm just that good. Minus MHU. Whoop. And so now we move this over to this side. Speed run. Yeah. Because what you have to do is you have to write a 200 to 350 words. Which I do like constantly. I think, hold on, actually, how many words is in my YouTube video? I think my voice, jeez, what the fuck? I think my upcoming video is like 6,000 words. If I remember correctly, I'm opening Word, Microsoft Word while I'm at it. And this is gonna be, yeah, no brush tool, please. Okay, let's see, how many words? 4,000 words. Yeah, and I have to write 200 for my homework. Yeah, 200 to 350 words, like a 20-minute essay. Exactly, I could do the whole homework in like an hour. Not as being Eminem. Yeah, but like I'm still afraid that I would miss the deadline for some reason. I don't know why. Actually, no, I have to add MHU to that, and then I'm gonna get MH plus MFC times V2. Yeah, I haven't even chosen the course. Like, I'm probably gonna use Coursera. I'm not quite sure if there's gonna be a better alternative, but I'm probably gonna use Coursera and study something kind of simple. Okay. And V1 is that, so it's gonna be. I'm not quite sure about what's going on outside. There's a siren going on outside. I have no clue what's going on. What the fuck is happening? I don't know. It sounds like. Okay, fun fact, I've never really recognized siren sounds. I think this siren sounds like an ambulance. I think. There are like I feel like there are like firefighter sirens. There are police sirens, and there are ambulance sirens. And I'm not quite sure. I genuinely can't remember which one is which. This one is no longer V1. It's gonna be U, and you add MH to that one. U. And it's going to be equal to MH plus MFC V2. And I could factor out the MH. I could have factored out the MHU. And then I can delete that bit. I can delete that bit. This part becomes 1, which becomes 2mH plus MFC divided by 2mH plus MFC, which is going to give us M1U, MHU. Up here it's going to be 3mH plus 2mFC divided by 2mH plus MFC, and then I divide the whole thing by mH plus MFC equals to V2. Autokill. Okay, and that's our answer. Which one is more though? Which one is higher between this up here versus this one down here? Let's see, this is So we're gonna have to find whether mh over mh plus mfc times 3mh plus 2mfc versus 2mh. Which one is higher? Damn, can't tell. I forgot to pay my electricity. Damn. Call that an ultra bill. Fair enough. Good one, good one. Alright, so yeah, that is our answer. Which one is higher though? Really, which one is higher? If MFC is way bigger, this whole thing, this term dominates, so all of that would turn into MFC, okay. Which one would be more? So really, I just have to cancel these guys out. We have to find whether or not 3mh plus 2mfc is more than 2. I'm genuinely curious, like, if you jump off first, or if you both jump at the same time, which one would be faster? And if we know this, we could probably do some rocket science with this, because we would know that should we expend all the fuel at once, or should we slowly release all the fuel? The answer is kind of obvious. You would probably, I think it's obvious, you would probably slowly release all the fuel. Yeah, it is. This one's bigger. How? While I was playing Smash, I got too excited, called that an outdoor thrill. Cool. Fair. Fair. You know, today, as I said prior, my professor isn't really available today because he's having surgery. I'm going to use all my fuel instantly, so I get thrust in one direction, causing me to not like orbit. Yeah. So my professor is like unavailable today because he has a surgery, and so there's no class today. Call that an ultra shill. Anyway, this question is done, and yay, there we go. We finished this. We finished our first problem. Oh yeah, have I talked about Silk Song yet? Actually, hold on. Before I do that, let me check what is the next problem real quick. I think it's before it was question 3.4, and then there's question 3.19, I think. It is 3.19, alright. Silk Song next week, I think. Yeah, I think it's in like, let me check the date. It's in less than 2 weeks. Yeah, it's in like, once it's Thursday, it's gonna be Silk Song next week. Holy shit, that's insane. I need to start getting money because I need to start farming the money now so I can buy it. Because I've kind of been a little broke recently. Okay, this question is divided into 2 pages because it's at the bottom of the page. I got diagnosed with more ADHD. I figured. Not a surprise. Gotta get an ultra pill. Hold on. My allergy is acting up. What else? Ultra. So the other day there was like this one class in biology. My friends were in the class in biology. They had like a giant shrimp thing called an outer krill. All right. Have I shown you guys the picture of the barbecue yet? I don't think I have. Hold on. Let me send it to my alt and then just send it and then put it on the thing. I'm not quite sure about whether I have to like. Don't know if I have to like blur someone's face or not. It probably doesn't matter. You guys probably can't dox me anyway. So when I was in camp, right? People were a little drunk at the camp. Barbecue. I think you have sent this to me. Yeah, I have. Yeah, give me a sec. Let me go grab that picture and put it on. Yeah, so I was at a camp and there were alcohols at the camp because we're all adults now. I didn't drink any, but I was just having fun, laughing at the people who were drunk, and it was a lot of fun. And call this an ultra grill because holy shit, this was insane. So yeah, I went around and find a few sticks on the floor, and I just had fun because I just grabbed all those little sticks and then put it in the barbecue grill and then just started. It was lit. It was really funny, honestly. Probably no fire hazard. I think my seniors knew what they were doing. But yeah, that was crazy. Stuff with the outkill puns. I'm sorry. I'm not really sorry, but you get it. And the clumsy ass kept dropping the water. Oh, that ultra spill. We know that the path of projectile thrown from the ground is a parabola. If we ignore air resistance, of course, because if it wasn't air resistance, it would not like that. If there were air resistance, it would look something more like that. In the light of result 3.12, which I haven't done, what would be the subsequent path of the CM center of mass of the pieces if the projectile exploded in mid-air? That's part A. A shell is fired from level ground so as to hit a target 100 meters away, and luckily the shell explodes prematurely and sorry. I'm actually crying. I'm thinking of if this is like a setup for another pun. Like, I'm trying to think of something that rhymes with ill. I can't. Okay. And breaks into two equal pieces. The two pieces land at the same time, and one lands 100 meters beyond the target. Where does the other piece land? And is the same result true if they land at different times? With one piece still landing 100 meters beyond the target. Okay, this is a little bit more challenging. It's still a 2-star problem, so I'm not really concerned about that. But what would be the subsequent path of the CM of the pieces if the projectile exploded mid-air? A, the answer is that same trajectory. Because I went to the cafe and asked for water, and they asked for what kind, and I said ultra skill. Shut. I'm unmodding you. I'm unmodding you from something steel wire. Yeah. So it's gonna have the same trajectory because of the fact that because there's no force acting on it apart from gravity, and the center of mass must still be the same. Yeah. I can't breathe. Okay. A shell is fired from level ground so as to hit a target 100 meters away. Unluckily, the shell explodes prematurely and breaks into two equal pieces. The two pieces land at the same time. One lands 100 meters beyond the target. Where does the other piece land? So if these two pieces land at the same time, we can say that it probably moves something like that, and then once it's over here, they explode into two directions. One goes like this, and the other goes like this. And two equal pieces means the mass remain the same. So if one lands 100, okay, wait one second. If one lands 100 meters away from the target, and the intended trajectory should have landed at 100 meters, would have landed at the target. That means the other mass has to go off by 100 meters as well. Why is this? Because from A, they have the same trajectory. The subsequent path of the center of mass of the pieces, if the projectile exploded mid-air, must be the same. Why is this? Because the velocity at the center of mass is going to be the same before explosion. Because there is no external force acting on the center of mass. Both forces that act on the object are equal in opposite directions. So it means that the total force acting on the system, holy shit, I needed a breather. Breathe in, breathe out. Calm the fuck down. VCM is gonna have it's gonna have the same velocity as if it hadn't been exploded, because the total force acting on the system is gonna be zero. One object, once exploded, is gonna exert force on the other mass, and because the other mass is also gonna exert an equal amount of force to the other. I'm fucking dumb. Okay. The two masses must exert force in equal but opposite directions as per as per Newton's third law, action equals reaction. Well, negative reaction. So therefore, the center of mass must remain unaffected. Yeah. Therefore, the center of mass must not be at the same spot. No, the center of mass must still be the same. Therefore, the center of mass must be at exactly at the range at where we shot it at. Where we suppose it should have been. I'm gonna make it out. Oh my god. I regret not unmodding you. So we shoot this, and then it splits into two. One of them landed 100 meters further away than it should have. So the other must land 100 meters shorter than where it should have, which is where we were. Therefore, in a comical twist of events, this problem tells us that if we shoot this guy over here, use filter alpha from chat. Good idea, actually. That probably works. Yeah, and then it explodes over here. The projectile is gonna land back at us, and the other one's gonna land all the way here. And in the distance here must be equal to the distance here, because that's where the center of mass has to be. Both masses are equal, so the center of mass must be right in between. Okay. Next up is C. Is the same result true if they landed at different times? This is immediately false. Yeah. We can prove this by playing Angry Birds. There's this little bird there. I'm not quite sure. Was it? Is her name like Matilda? Anyway, I gotta go fix my car. I'm okay. Wait. Yeah. You can go and fix your car. The worker said he needed an outer drill. That doesn't work. I don't think you use a drill in a on a car. I mean, there are probably some other thing that you use, but like, yeah. I don't think you use a drill on a car, unless I'm wrong. Okay, Angry Bird. Who's the white one? Matilda. Yeah, the white one's name is Matilda. So obviously, it does like Angry Birds. So we shoot Matilda over here, and then we explode her there. The egg is gonna come down here, whereas she's gonna go the other way. And obviously, the same result must not be true if they land at different times, because over here, initially the egg is gonna go down at this whatever speed, but the object is gonna go up at a different speed. But the total momentum is the same. Yeah, the total momentum must remain the same. That means the center of mass must still be at 100 meters. The center of mass must land at wherever we suppose it was. But the problem here is the fact that the center of mass is not going to be. The center of mass must not be at that point, because once it has landed, there's going to be force acting on it now. There's going to be force acting on just half of the object. On this half of the object, whereas this object still hasn't landed, so the only force acting on it is still gravity. So that means because once it has landed, the center of mass is going to start to move. It's going to start to move upwards a little bit, and then it's going to fall back down. So I think this is false. I'm quite certain, because now there will be external force acting on the object. Because now, once it's landed here, this one is no longer falling with. This one's gonna have external force acting on it. That is, there's gonna be some force that's gonna push this object so that it doesn't. So that it stops going to the left. Over here, when it falls down, it goes to the left and down, right? And then it stops going to the left and down because there's a force from the floor pushing it up and to the right. So that means the center of mass now is not going to be at 100. The center of mass is going to be moved a little bit further over here, and then once this guy lands, obviously it's going to go like something like there. The center of mass is going to move a little bit, and then the object is no longer going to be at. And so the center of mass is going to be here, and the object is no longer going to be 100 meters away from this other object. I think that makes sense. I hope that makes sense. What I'm saying is, the reason that the same result is not true if they landed at different times is because there's going to be some external force acting on the system now, because of the floor acting on the system, making the object not slide further, or making the object no longer. There's going to be an external force, so the center of mass, the trajectory of the center of mass changes. Therefore, it doesn't land at the same spot as we wanted it to. Yeah, that's. I feel like that's a solid argument. And fortunately, there's no calculation needed to be done for this question. The next problem is 3.25. 3.25. Angular momentum for a single particle. Okay. Let's see. Are we actually out of outer kill puns? I think we're out of outer kill puns. We're good, guys. We are saved. We're saved. He can lines. Okay. No more auto kill. Yeah. Like, no, this still was on top. Yeah, I guess you would say, so, wait a fucking minute. You're gonna say that, aren't you? Yeah, I saw it coming. Not gonna get me this. You did get me, but still. Yeah, I knew it. Now we're going ultra downhill. Alright. Well, yeah. You know, alright. A particle of mass m, blah blah blah. I gotta admit though, Neon, you coming up with all of these, it takes quite a lot of outer skill. A particle of mass m is moving in a frictionless horizontal table and is attached to a massless. Oh my fucking god. Wait, this is easy as fuck, what the hell? Well, I mean, okay. I'm way too happy with this joke, bruh. Okay, this question is actually kind of easy. Alright. So let's just do that. So let's draw this setup. I've actually done a more advanced problem called an ultra fulfill. Bro. Okay. Okay. Although, you know what? I won't blame you considering I've made worse puns. You guys remember that William Afton puns I did like years ago? Or that Nintendo Direct pun shit that we did on Neon server. Yeah, I think like there's like the continuation of that. There's like part 2 and part 3. Alright, a particle of mass m moving on a frictionless table. I love how they had to clarify that this is a horizontal table. Like, thank you for clarifying that the table is not setting up like this. Which, honestly, yeah, I could see that. I could see someone thinking of that, but whatever. Thank you for clarifying that this is a horizontal table. See, if I go silent because I'm trying to think of more puns. I can't. Alright, moving on. Okay, and obviously a particle of mass m, gonna make this thing, does this assemble the table? No, it's gonna ruin the experiment. Alright, so this guy's gonna be going around in a circle. And yeah, a particle mass m is moving on a frictionless horizontal table. With, of course, there's going to be a rope pulling it. There's going to be a rope pulling it with some tension force T. It doesn't matter what T is. What we really care about is the fact that T here is pulling the object inwards radially. Which means that it's going to be R cross T R cross the vector t, which is going to be 0. Because the cross vector of two parallel vectors, the cross product of two parallel vectors must be 0. And this value is the torque. And it's 0. Therefore, when there's no torque, what is torque? Chat, what do you think torque is? Correct. Torque is the change in is the rate of change of angular momentum. Yeah, this joke is legit an ultra roadkill. Shut the these puns are getting unfunny and I will die on this ultra hill. Alright, so that means that the angular momentum, the change in angular momentum, well, share godlighting.png. The change in angular momentum must be 0. Therefore, Now you know how I feel. Okay, so that means the angular momentum must be constant. Man, this is too fun. Why haven't I done this before? Oh no, I've corrupted him. He's gonna be making a lot of puns from now on. This is like character development. L is a constant, therefore if we take this means that angular momentum is constant. Angular momentum is constant. This is really this question is actually kind of easy. I didn't expect it to be this easy. Angular momentum is constant. Now he's gonna do more autokill jokes. Yeah. Okay. But like, yeah, just if you don't just yeah, don't laugh too much, all right? Or like, yeah, you just gotta calm down, breathe in, breathe out. I don't want you to. I legit went to a large farm and had an auto windmill. Shut up. Just if you don't laugh too hard, you're gonna be if you laugh too hard, you might get sick and be ultra ill. Angular momentum is constant, which means that L here, by definition, the angular momentum is R cross V. No, not R cross V, sorry. R cross MV, which is R cross P. Which is the cross product between the position vector over here, the vector R over here, and the momentum P vector over here. And so R cross P here is going to be R naught R cross with the velocity mv along the theta axis. Theta axis, of course, is the tangential part of the circle. Is the tangential axis. Now you know where I live, right? Yeah, I do. Why? I do know where you live. I could go there. I got an outer sand hill. I'm gonna come and eradicate you. Yes. Okay, so mv here is gonna be m times r naught omega naught. Because that's the velocity. I'm so sick of this still call me ultra ill. Please. Why am I still going with it? Whoop, and then obviously now we multiply that. We have m r naught squared omega naught, and then this is going to be along the z-axis. This is the cross product of the vector. The cross product of the vector is perpendicular to both vectors. In this case, it's going to be pointing out of the table, outwards from the table. This is the z-axis. And so we know that this must be constant. I'm laughing too much. I'm getting a really bad headache. Come on, Neon. Go on. Go on. Go ahead. Say it. I'm waiting for the punchline. I'm not writing my next line too. I'm gonna. Okay. Okay. You know that's good. That's good. That is okay one. That one's okay. Alright, so that means that the initial angular momentum, which is mr squared omega squared, no, not omega squared, omega naught on the z-axis must be, okay, honest to God, I'm done, 100%. I'm waiting. Is this like, are you setting up for another one? We're setting up for another one. There's gonna be mr squared, and then there's gonna be a new omega. I swear. Okay. I see. Okay, yeah, my brain just got paused a little bit. I don't know. Just sorry for going ultra skill there. All right, so this is just conservation of angular momentum. I will continue to think of stuff I couldn't, but I'm legit all out. Okay. So we cancel out the m. We now have omega, which is going to be the final angular velocity. What the hell happened here? A lot of ultra kill puns. Somehow. So angular velocity is going to be equal to r naught squared omega divided by omega naught divided by r squared. And this is our final answer. It's just that easy. That's conservation of angular momentum, because now you pull the string down through the hole, which means that t increases, but ultimately it doesn't really matter because torque is still 0. Yeah, it started with V1, V2, and this one, like, I had to denote that the initial velocity, I'm gonna call it V1 ultra kill, then V2 ultra kill, and then it derailed from there. And so the final angular velocity is that. Easy. Alright, well that's done. That's my that's my homework. Yeah. You don't think there's anything else that I missed? I'm pretty sure I got there are 3 questions, right, in my homework. I'm pretty sure I do have 3 questions on my homework. Yeah, that's it. That's it. We're done. We're done with this homework. I can end the stream now. Just kidding. Let's do one more thing. 1280. Wait, is it 1280? Yeah, and 720. Boop. Boop. We're doing one more thing, and it's making the thumbnail for my next video. I have exported the video, yeah. Also, you guys want to see the infographics homework I did the other day? It was for the science communication class. I made this little, one sec, I can't find it. Where was it? Yeah. There's this, little homework, I mean, not that one. Not that one. I made this little infographics homework about how CRTs work, how CRT televisions work. Like yeah. Like I didn't have any ideas, but like I was like listening to a song and then figured out that, oh, I should do about CRT. So did you know that CRTs work by like, CRTs are technically like small particle accelerators. Yeah, CRT TV. Basically, you start with an electron gun. What you do is you have a cathode, the part that like emits out an electron by heating up a lot, and then it shoots out an electron through the anode, and the anode is like the side that's like attracting the electron. But then there's a hole in it, or there are some cases where the anode basically focuses the electron beam. And then the electron beam is then sent through through some coils, and these are funny thermionic emission TV. Yep, it is called thermionic emission. The coil then uses magnetic field to steer the electron beam. It does come straight from your house. Yeah. And then there are 2 sides so that it could steer it in both x and y direction. And then the electron beam then hits the phosphor on the screen. and it causes the phosphor to fluoresce. It's called cathodoluminescence, and the phosphor depends on the color. Some phosphor will glow red, some phosphor will glow green, some phosphor will glow blue. Oh shit! I was wheezing so hard that my throat legit hurts. I'm glad you had fun. You know? I'm glad. So like this ended up being a display for RGB. Then there's also the shadow mask thing that can filter out it. This electron gun will only be able to shoot at the red pixels, the red stripes on the phosphor screen. While the other ones, the shadow mask will filter out only the corresponding colors. So this allows its CRT TV to be able to show you the screen, the color screen. I still have a CRT, a very old CRT TV in my home. I used to watch it when I was like very young. Can't remember it anymore. I think it's still in my dad's. I think it's still in my dad's room. So yeah, that's a really neat thing. All right, let's see. Special relativity. I want to make the thumbnail for my special relativity video. Probably won't finish it entirely now. Just gonna almost finish it. Where's my Minecraft font again? Where did I put there it is. There's Minecraft 7, there's Minecraft font. I prefer Minecraft 7. There's Minecraft math font. I tried to make I use Minecraft 7 here as a basis and then just copy paste everything and try to make it mathematics. As in like so you'd be able to write equations with it using LaTeX. It failed, so I ended up not abandoning it. It's just gonna stay there on my computer now, but yeah. Alright, let's see. Special relativity. And I set it to like this font size. This font size good. I feel like it's good. I said it right. Yeah, it's probably right. Now what do I do next? What will give you what makes you think of special relativity? Clock and spaceship, right? What else? What else can I name? How about use the enchanting table? Name it, no. Like legit, I was crying on the floor because of how many puns I was making. You gotta ultra chill down. Chill out, not chill down. What the fuck am I saying? Okay. I said calm down and chill out at the same time. Right. Special relativity. What else can I do here? I wanna use Einstein's portrait for this. But I already used it in that older video of mine about Brownian motion. You guys remember that? You guys remember that video on Brownian motion? It's we're on ultra chill now. What are you on about? Okay, cool. Let's see. I'm gonna talk about like Brownian motion. Like I used Einstein in my thumbnail before, and when I talk about Brownian motion, I don't know what can I do now. What will be a good way to make people, guys, chat, what do you think? I'm streaming this because I also want your feedback. What would you guys think of when I say special relativity? Because I don't want to just slap down the math formula on here. Obviously, that would not be good for audience retention. Special relativity, what can I do? Before that though, I like these little effects called chromatic aberrations. So let me just do that, I guess. We'll just do this, and then I shift this thing a little bit like that. And then, yeah, and now I make this thing. One sec. Modify channels. There's this little neat little plugin called Modify Channel that just makes it. They can modify the RGB channel. So here we have this little thing. Now I change this into additive. And you can see that there's going to be a little bit of a offset bit across this. And so I do the same thing to this channel, and now I apply the same modify channel, but now it's going to be green and blue. That are going to be zeros. That are going to be set to 0 instead. And now we have this little RGB chromatic aberration effect. Made red and blue. Good idea. Good idea. I should have done that. Right. Yeah, I gotta change that then. I gotta change the colors then. Give me a sec. Adjustment. Brightness and no, not brightness. Contrast. Hue and saturation. Yeah. And I flip that a little bit. Can we go for more? That, why is it, actually no, it's not supposed to be green. What am I doing? I mean, Neon would ultra loving it. I thought we were doing homework. I finished my homework. Right now I'm making the thumbnail for my video now. Neon. It's what? Yeah. Then that's a little bit too little. You know what? I'm just gonna apply the chromatic aberration to the entire image for 5, I think. No, wait, 1, 2, 3. But no, delete that. Copy that. And now we have 2 layers. And now I move the top layer by like that much. And then I make sure that this one is gonna be, make sure this top one is gonna be red. No, wait, no, that doesn't work. How do I make it? How do I make it blue on the left side? Oh, no, this is correct. This is correct. Yeah, I'll just do that. No, it's not really correct per se. I can invert the colors later. Never mind. No, I shouldn't invert the colors later because it's gonna turn the black into white. This one turns green into that. This one is gonna be setting that to 0. Yeah. No. I gotta apply that to the top layer. Sorry. I apply that to the top layer. It's blue, constant 0, blue, and then yeah. And now we have this red thing going to the right. And then we're gonna have the blue thing going to the left. Red set to 0, and boom. And then I make this, turn this into the, use an additive, adding, and yo, look guys, chromatic, it's the neon color scheme. Whoa, shit, I almost fell off my chair. It's the neon color scheme. Okay. So, spatial relativity, what else can I add to the thumbnail? Gonna apply that. Gonna add that to the same layer. Okay. What else should I add to the thumbnail, guys? I want to add Einstein's portrait. How about this? Minecraft Einstein skin. There it is. Let's see. Do I have the license to these? It gives me VHS vibes. Yeah, it does. Chromatic. It's called. This effect is called chromatic aberration. It's very prevalent in VHS effects. Special relative. I don't want to put in stuff like black holes. If it's VHS, then we need green too. No, is it? Yeah, there are some chromatic aberration effect that uses green as well, but it's typically not that. What do I want to put? You want to put? Can I just? I don't know if I have the license to the skin because again, this one is for Sum 4. So like there's like a proper, what is it? There's a proper video that I would have to submit. I'm not sure if I am allowed to use any of those. You know what? I'm gonna use Einstein, and then just gonna paste his picture on here. I don't want to overuse Einstein's image though. Kind of don't want because I used him before in my video on Brown in Motion. Okay, this is work. Now I have to like trim it a little bit. I'm kind of too lazy to do that. Can I just slap this up? Can I just hold on? Normally, if it's Photoshop, right, that would be like the magnet tool that would help me with this. That would help me with this, but I kind of don't have Photoshop. Okay. No, there's still that little thing that I kind of want to secret the Einstein. Should I put this? I don't want to use Einstein too much. Because, okay, if you go ahead and check out my channel, right? Let me share my screen of my, let me share my OverGX screen, yeah. I don't really overuse the Einstein too much because in my older videos, okay, does this link to my channel? Yeah, this does link to my channel. In my older videos, there's this one that I already use Einstein in. I don't want to put him in two thumbnails this closely. Like maybe in like a billion years, then I would probably use Einstein in the picture again. But I don't know. I don't want to do that. Okay. How about I discard this Einstein right now and see what do you guys think about when it comes to special relativity? What do you usually think of would actually be something like a I don't want to use that. You know what? Sure, I will. I'm gonna put in Minecraft stuff in there as well. And I'm gonna put in a clock. I feel like that's a decent way to make it. To make the thumbnail. Because like, you know, when it comes to spatial relativity, of course you think of stuff like time and shit. But like, how does that look? You know what? I'm gonna open another tab and see special relativity. We're just gonna straight up Google it and see what people think of it in the images. Why are they? Why is there curved space-time in special relativity? There should not be curved space. Oh, right, the light cone. Completely forgot about that. Okay, yeah, I should draw the light cone. Although in the video I didn't really talk about the light cone. I feel like it's still relevant. So so I'm gonna use it here. Is it not cool? It's not aligned. Let me move that there. And now I can move this over here. Now there are and now we have the same the share point. And then I try to make the cone, light cone, by adding in something. I've already used a little bit of those colors. I think I'm gonna use cyan a little more because I think. So from what I've heard, I should stick to a semi-consistent color scheme for each project. For example, for this one, I've heard that I should use like a little bit of consistent colors. So I do this, and then I copy that, I move that down here, move it straight down. Okay, and that should be good. And then I use a line to connect them. Okay, before that though, I'm gonna delete this bit. Delete that so it looks like it's going behind it. Actually, no, I don't. I'm not gonna do that. I'm gonna do this, and then I'm gonna select half of this. No, my viewers, it was at 9 for a second there. I was so happy. Never mind. Or I could just set this this section's alpha value to be 1. How do I select it? How do I select half? There we go. Look. Okay, and boom, there we go. And then I do the same to this one. Yeah. Okay. And delete that. Delete that. Just want a triangle, so that it means that that pixel's alpha value is divided into divided by half. Divided in half, yeah. Okay, and now we have the proper, quote-unquote, proper light code. Why did I genuinely waste time doing that? Whatever. And now with the light code, I can use this, and then I just draw this straight through. No, my mouse double clicks. My mouse tends to double click. I feel like it's a good time to start changing the mouse. Whoops. Okay, and then I do that. Now we have ourselves a light cone, which is not centric. Not centered. Now it is. Okay, yeah, that's a light cone, alright? Yeah. And then I fill that in a little. Whoa, shit. Okay, I fill that in a little. Turn that off, fill that in. Fill that in, fill that bit in. Fill that bit in. Gonna temporarily make a little line up here. Make a line up here temporarily, and then I come back here and fill that in, and then I delete that small little line. And now we put that back in here. Yeah, the light cone is a little bright, so I'm gonna lower that. What? Oh, I put it on the wrong layer. Okay, wait. Boop, boop. Fill that, and then I use that, and then I fill. I put it on the wrong fucking layer again, bro. Please. Okay, I'm kind of stupid. Yeah. All right. Fill that in, and then now I can. What's this? Okay. What's this layer? Okay. I have to start checking the layers now. What layer is this? This layer contains nothing, so I'm just gonna use a paint bucket in there. I put it in the wrong. Okay. New layer. This surely won't go wrong this time. There we go. And now I delete that layer. And then I bring this layer back, and there we go. Now this layer doesn't have a use apparently, so I'm gonna delete that so I don't get confused. And then this light cone, gonna lower the opacity, and now we have a pretty good light cone. Chat, what do you think? Oh, what the fuck? Okay, chat, what do you think? I'm gonna call this text. Yeah, light cone there. I'm gonna call this light cone fill. I just realized you guys don't see the layers window. There are layers window. But in Paint.net, but it's not showing here. This is space-time diagram. And this one over here is light cone border. Boop. I'm gonna save this for now, and I'm gonna put it in the thumbnail folder for my YouTube videos. Thumbnail, boop. And then I name this thumbnail.pdm. Okay, and then the rest, it is pretty good. Holy shit, this feels like a 3 blue 1 brown thumbnail. Pixelated. Oh yeah, because of colors. Ah, right. Actually, how would 3 blue 1 brown do it? I feel like this is a better question now. 3 blue 1 brown. How would 3 blue 1 brown make a... Why does it direct me to AI mode? Why does Google tell me to... Okay. Let's see. 3 blue 1 brown. How does he make his thumbnails? Yeah, it feels a lot like 3 blue 1 brown because of the cyan color. The cyan color is like 3 blue 1 brown coded. Why is this off? I'm gonna move this thing a little bit. Okay, back here. Okay, now it's not off. do minus AI to remove the AI shit. Alright, we'll do. Next time. Okay. How does 3 blue 1 brown do it? I see. So I might not want to overuse that. What do you think? What's that thing called again? The light cone? The one in the thumbnail? It's the light cone. Yeah, the light cone. How about that? If I Google the calculus explained in Minecraft terms, I think there's those videos. Calculus explained in Minecraft terms. Yeah, there it is. I could probably use those. There's actually a lot of calculus in Minecraft terms. Actually, there are two mainly. What do I do? How does that work? It's a black background for this one. Okay. Yeah, how about we add in something more Minecraft related? Because right now the only thing that indicates that this video is a Minecraft related video is the special road. Oh, right. I should use the spaceship. I could build a spaceship in Minecraft, and why does this look off? It is off. It is off. Wait. But when I move it here, this one no longer aligns. Okay. One sec. OCD is acting up a little. Sorry, guys. Okay, I have to move this hole over to this, and then I copy that, and I move it here instead. And the same thing applies here. I just move this. I move this guy over here, and then I copy that, and I move this over here. Okay, cool. Now we're good. We're good. All right. Yeah, finished it. Finished it. What do you finish? What else would make you think of spatial relativity in Minecraft? Minecraft clock? I could build a clock in Minecraft right now. Yeah, I'm gonna build a Minecraft clock right now, then export it as and I'm gonna export it, and then it's gonna probably, why, I don't think I need to do it in Minecraft. I think I just need to make it pixelated. So I'm gonna make it in 16 pixels. I can just make it pixelated and then upscale it a little bit. Let's see. Clock. We're going to play Skyblock now? No. No. That's right. No. Is this circular enough? Wanna play create mod? Not right now. I'm gonna make this. I'm gonna finish up this this thumbnail real quick, and so you guys will also see it in action. This looks circular enough, I guess. Okay. Tolerance a little bit less. No, never mind. Okay. Then I'll just select that and then fill it with white. Okay. Sorry. Got a little dirty-minded there. My apologies. Now, how do I make it a clock? Because I don't think this is symmetric. Because you can't make it at the exact center. Well, damn. Okay, let's see. How would you make a Minecraft? Would you make a clock? I know there's a Minecraft clock, like an actual item that's Minecraft clock in game, but like it looks nothing like a clock. Oh! Neon, you are so goated for this. Okay, yeah, this. Okay, so guys, here's what Neon sent me actually. Thank you. You are. I knew it could draw. I knew. This is Neon's thumbnail. What he did. Yeah, this could work. I feel like I want to remove the text on that one though. Yeah, I think I'm gonna work with this. Using this design. Yeah, I could work. Thank you, Neon. You're a goat. You guys should. Yeah, you guys should go subscribe to Neon as well. If you're subscribed to me, he's not. He's not like as big of a nerd as I am, but his content is also pretty fun. It is good. Yeah. Okay, I'm gonna make this. I see. Okay, I got it. I got nothing. I tried to find transparent, but got nothing. Yeah, okay, I can recreate that. Hold on. I can make it like that. I'm gonna go grab that light cone back here. Yeah, I'm gonna make that without the text. Okay. You know what, Neon? Thank you. That is a great idea, but oh shit, it's 8:30. Okay, I'll be working on that. I'll be practically copying this, but with a little bit of a minor adjustment because it's cool. This is really sick. I'll ask you about how you did this though, because I don't know if that's a thing I could do in Paint.net. But yeah, thanks a lot. Well, that practically finishes my video. I just need to refine it a little bit more, and then we're done, and I'll be able to finish it. I can do it for you if you want. That would be great. Let's talk about this after my dinner. But for now, though, thank you for watching, and thanks a lot, Neon, for the thumbnail. And yeah, you guys have a great day, or night, or afternoon, or anything. Yeah, thank you for watching. See you guys later. Bye.